All right, guys. So here's a piece of good news. We're gonna only go up through 4. Let's see, where is it? Section 4.3. Yeah, for this next test. We're not gonna do 4.5. I'm not gonna slam that in today. We're gonna only go through 4.3. We still got to talk about cubes, and then we still have to talk about solving equations using factoring. So I'm not going to try to slam 4.5 in there also. So this next test will only go up through section 4.3. You guys with me? So you only have to turn in homework through 4.3. So let's see, what did we do last time? We did this kind of thing. Let me see if you guys remember how to do this kind of thing. Now, understanding that the name is not nearly as important as knowing how to do it. Does anybody know the name of this thing? The name of this form?
Yeah.
Can you make it like just a little more specific? Like, there's also some English up there, some Y's and B's. You can spell the word by. It's also ink technology. It's marker technology, and a little bit of marker high too. So, chemical reactions in the brain. All right, sorry. So some chemistry, but more specifically, what factoring form is this? It's a what is this? Is this a sum? This is a what? Is this a sum? Is this a sum? No, it's a what? Duh. Difference of squares. Okay. So it's two terms. It could only be squares or cubes. We haven't talked about cubes yet, so it must be squares. All right, let me stop there for a second. So again, like I said, though, I just said the name wasn't nearly as important as knowing how to do the problem, but still, you should know kind of like what this thing is called. How do I factor this? Why is this a really, really, really nice problem? Because the only way the middle term can cancel is if everything's the exact same except plus and minus, so that the middle is the same stuff except one's positive, one's negative. So in the middle I would get negative 7by, but then I also get plus 7by, and that's why there is no middle term. But what allows these to be opposite signs is the fact that it's a difference. So how do you factor this? What's 5 times negative 5? So the reason this works is the same reason this don't. Right? Because it doesn't allow for different signs. If it don't allow for different signs, it ain't going to work. Because if the signs aren't different, will the middle term cancel? No. So if I thought it was x plus 5, x plus 5, why is it not that? Because the middle term be 5x, 5x, 10x. Oh shit. So maybe it's minus, minus, but of course that's silly because now I'm just going to get a negative 10x in the middle. So what is the actual answer to this? If I ask you this question, factor this, what are you going to say to me? You could say it's already factored, but even a little bit better, what kind of number is it if you can't factor it? Prime. I know somebody said that earlier, so I'll make sure everybody gets there. I really want that to make sense. The reason this works is it allows for these to be different signs so the middle term can kill each other, right? They can cancel. This don't have a shot then. There's no chance for this poor dude. You can't let the things be different signs. Alright, so you guys try this with me. What you got, John? I don't know. I like it. This one is slightly evil. Slightly. So if you don't notice something at the beginning, you can just start to do this. And how would I fill this in? Yeah, it would be 10, because 100 is 10, 10. M4 is M square. Minus plus, 25 is 5 and 5. Z8 would be Z4. If you stop there, I'm going to take points off, because, you know, I'm evil like that. Just randomly select places to take points off. I don't know if you've noticed that yet.
You can take out the greatest college.
Yeah, there's still stuff in there I can take out. In fact, at the very beginning, I could have taken out a 25. Do you guys see that? There's a GCF here. There's a 25 that I could have taken out. But what do each of these have in them that I can take out? What does this guy have in it that I can take out? A 5. So that's got a 5 that I can take out. That's got a 5 that I can take out. And when I put those together, I get the 25 that I could have taken out in the first place. So out of here comes a 5. What's left inside? And out of here comes a 5, and what's left inside? The same thing, but a plus, right? So 5 times 5. Wow. So when I say factor, I mean factor completely. You can't just stop when there's still something that can be taken out. So I could have done this. Take a 25 out first, and then this would have been 4 minus 1. Do you see that? And of course that would have been broken up like, oh, what did I do? I left out my poor little other dude. There we go, Jack. Good job. So that would have been broken up like this. So 5 times 5 is 25, and then this times this, I just put there. Good me. So you could do the GCF first, or you could do this GCF thing last. The math doesn't really care. You just got to realize it's got to come out. Okay. All right. So what about this? Which guys? Factor that one completely. Kind of happy it's taken you guys a little while, because if you don't realize something is real quick, but there's more to it. X4 I could break up as X squared minus plus, and 16 is 4 times 4. Which one of those is not done yet? There's only one of them that's not done yet. The first one, because it's a minus, so I can do a difference of squares all day long. Sum of squares I can't do anything with. All right, we talked about that earlier. So this guy just comes for the ride. He's done. He just comes for the ride. And how do I rewrite this guy? So anywhere I see this, I can rewrite it as x minus 2x plus 2. So see how if the power is higher than 2, there's a chance that there's multiple steps. Alright, cool. Maybe. Okay. Let me show you something here. Well, let's see. I'll do that later. We'll do this one first here. Let's talk about. Let's round out the whole factoring. We got one last form of factoring to talk about. We're done talking about forms of factoring, and then we can start talking about what the hell you can do with it. You're able to break them up into parts. Yay! What can you do with that information? So cubes seems like, like a really good first guess. And you can see why I call that cubes, right? Because x cubed is x times x times x. 8 is what times itself times itself? 2 times 2 times 2. So they're both triplets. They're both cubes. So this is wrong. This is wrong. Wrong. But a decent guess that's wrong would be maybe to do something like we did here and say, let me break it up into 3 parts. X minus 2, x minus 2, x minus 2. Right? Doesn't that feel like it should be right? So horribly is not right. So let's check and see why this is not right. If this is correct, this is wrong. Please, dear God, don't go telling some tutors, yeah, my teacher said do this. Wrong. Right? Feel like Donald Trump? Wrong. Wrong. So if I multiply this out, what do I get? What do I get when I multiply these out? I'm going to leave this last little x minus 2 just sitting there. Let me multiply these out first. What do I get when I multiply these? X squared minus 2x, so minus 4x, is that cool?
Yeah.
And then
Minus 4. Or minus 4.
cool. And then I can multiply these. I'll get x cubed minus 2x squared minus 4x squared. Let's see, plus 8x plus 4x. I'm just doing this a little bit fast because minus 8. It doesn't work. I get nothing cancels. All this shit does nothing. None of this stuff cancels. Man, what the freak? Do you see what's wrong? If this is the correct way to factor it, then I should end up with this when I multiply that. That only makes sense. Right? If you say 2 times 3 is the way to factor 6, well, 2 times 3 is 6. Okay, good. Then you're right. Well, when I multiply that, did I get this? Hell no. I got this shit here still. So I was looking through, and a lot of you guys got that very last problem correct on the quiz. Do you remember that very last problem? A lot of stuff canceled, or should have canceled. So now watch this. This is kind of interesting. Take a second and multiply this out here. Alright, so catch up to you guys. Get x cubed plus 2x squared plus 4x minus 2x squared minus 4x minus 8. That's what we want. So there's what I call a little dude times a big dude. Or more technically a binomial times a trinomial. But I like little dude times big dude for a cube. That's what I need. Do you guys see the connection here a little bit? This is always going to be twice as big in the wrong sign as what this would have been. There's nothing there to use to do this quicker. There really isn't, but it's just an interesting side note. So I want to keep this going now. Really, let's analyze what happened here. So if I had, for example, let's do another y cubed minus 27. Because some people have trouble with this middle term, for example, why that's got to be there. Because look here, isn't this like y minus 3, y squared plus 9? Let me just leave some room there because this is not right. But you see why somebody would think this, because what's y times y squared? Y cubed. And what's negative 3 times 9?
27.
Negative 27. But what do they forget? Oh shit, I get extra shit that I don't want. But this is kind of nice. So far, this kind of makes sense. What do I do with difference in squares? I cut them all in half, and I put half in one and half in the other one. Why can't I do this here? Because I got 3 of everything. So what do I do then? I put 1 of each in there, and then the other 2 of each in there. So far, I let that make some sense. If I got 3 things, what's one way to break them up? Put 1 there and 2 there. So I put 1 y there, 2 y's there. 1 3 there, the other 2 3's there. So now I need a middle term to come in and clean it up. So I always think about like Pulp Fiction. Remember that guy? You guys have seen Pulp Fiction, right? If you haven't, your life is incomplete, right? That whole scene where they unfortunately shoot that dude's head in the back of the car. Remember that? And they have to. I'm sorry if that offended you. Too bad. They have to call somebody, the cleanup dude. I think he was called the Wolf. Is this right? So that's the cleanup guy. So I always call the middle dude the cleanup guy. He's got to come in and clean up the extra shit that I want, that I don't want. So what do I get here that I want? I get y times y squared is y cubed. And I get negative 3 times 9 is negative 27. What do I get that I don't want? I get negative 3y squared. I don't want that shit. And I get plus 9y. Alright, so the explanation of why something works always makes it sound worse than what you actually have to do nuts and bolts wise, so stay with me. So what I actually have to put here is something that when I multiply it by y, one of these will cancel out, and when I multiply it by negative 3, the other one of these is going to cancel out. So negative 3 times what is negative 9y?
3y.
3y. And what's y times 3y? Positive 3y squared. So y times 3y is, that kills that shit. I didn't want it and that killed it. And then minus 3 times this is minus 9y, that killed that shit. So now we got a couple of things up here that I can look at. Look at this 2x. Where are the 2 and the x? Where are they also up there? The 2 and the x. Where are they also up here? And there are 2 there? And the next there? Alright. The 3y, where are they also in here? The 3? The y? So that middle dude will always be these 2 things combined, product. Alright, so here, let me attack this, let me do a fresh one and show you. So that was the explanation about why that is what's going to work. So if I see this kind of thing, m cubed minus 64. The first thing I want to do for myself is break them up. M cubed is m. What's 64? 4. Then I make a little dude and a big dude. And let this first step just make so much insane sense. The little dude is a little tiny dude. Right? A little dude. So you can only fit one of each in it, because it's a little dude. So I can put 1m minus a 4. So in order to make m cubed, I better put what right there? The other 2 freaking m's, right? Just like when I have a square, I put x squared, I would put 1x there, and the other x there. So overall, I get my 2 x's that I had to begin with. So I put 1m there, I got to put the other 2 m's there. What do I put at the end? I put 1, 4 there, I got to put the other 2, 4, 16 there. This is always positive, by the way. Because really, if you think about it, a slightly better way to teach this that I thought about a while back is negative 64 is negative 4 times negative 4 times negative 4. And what's negative 4 times negative 4? Positive 16. That last one is always plus. So I put 1 of each, 2 of each. Why does that by itself make sense? Because I got 3 of everything to begin with. Okay, bullshit. So that's very similar to squares. Instead of cutting it perfectly in half, I got to cut it in 1/3 and 2/3. Right? 1 of each and 2 of each. Now to make this work, what has to go right here?
4m.
4.
Yeah, 4m, and what's the sign got to be so it can cancel the other shit out? It's got to be the opposite of this. Become a plus. There you go, John. So there is this little saying that I used to not use, but I think I've bought into it a little bit more. I'm not the biggest fan of mnemonic devices like foil. I don't know if you picked up on that. But this one is kind of nice. This sign is the same sign. This is the opposite sign. And this one's always positive. So, soap. Sure, if you like that, great. I don't like using that kind of thing too much because it takes you away from the math a little bit. So you're learning all these little sayings and you're not really learning the math, but hopefully you see why that's true and then you can remember it using that thing if you want to. So what I'm trying to say really is, help me out here. What's 2 squared? 4. What's negative 2 squared? 4, right? So squares can't handle plus and minus because it only has like one output. What's 2 cubed? What's negative 2 cubed?
8.
Negative 8. And what's 2 cubed? Positive 8. Is everybody cool with that? So cubes, basically in general, odd powers and odd roots are laid back. They're like, if you're positive or negative, no problem. Even powers, even roots, they're like, oh shit. Right? Even roots can't have negatives inside of them or else they become not real. Even powers can't have negatives coming out of them. Right? So to me, even powers and roots are kind of like uptight. Odd powers and roots are like, whatever. It's all good. So what I'm trying to say is, I can do something like this. I can factor this. So how do I do this? X cubed, of course, is x times x times x. What's 27? 3 times 3 times 3. So then I get little dude, big dude. What goes into little dude? An x plus a 3. So these have to go here. These have to go there. That's always positive, right? And then what's the middle term got to be?
3x.
Yeah, negative 3x. Done. 1 of each, 2 of each, product in the middle. La-da-da, make it a song, I don't even care a little. I don't like, there's a lot of songs people use to remember shit, but again, to me, that's taking you away from the math and you're just remembering a song. That's no good. But, you know, what the hell. 1 of each, 2 of each, product in the middle. That's as close as I come to a song. I like it. Maybe. So again, just check it out. So here I got x cubed and I get 27. So far that looks good. Here I get 3x squared, but that's negative 3x squared. See, the cleanup guy killed that extra piece I didn't want. Here I get 9x, but here I get negative 9x. So that shit cancels out too. So I do only end up with the x cubed and the 27. That's all I end up with. Same way that happened on your quiz if you did that last one correctly. Alright, so here, you guys try this. Running out of numbers, that'll work. Let's see. Well, let's just do, yeah, sure. Factor that. Alright. So a cubed is a 8 is 2. So in the little dude I put, like a little dude, you can always take one of each for a little dude. So I must put these two, good, minus 2a plus 4. Done. The big dude, you can never factor in. If that was twice what it is, always, it'll work. But this is always like half of what it's supposed to be. It will never factor. The big dude will never factor. Do not waste time. Do not pull your hair out. Only if you left a GCF in there or something could it come out. But in general, this cannot factor. Don't waste time. All right. And this is going to be not exactly something that will help you see why we need to know how to factor, but I got to give you something right now. If I had a cubed plus 8 divided by a plus 2, now please, dear God, I can't just cancel an a out. Do you guys see why not? What's division the opposite of? Multiplication. And what operation do I have here? Addition. So division can't do shit with pieces of an addition problem. All day long, if I had 8 times a cubed over 2 times a, now division can kill parts of that because it actually is the opposite of multiplication. It can do something about that. It can't do shit about this. So then how do I do this? I try to factor this, because what's in the middle of here? Multi-freaking-plication, right? Why did that come from? We already factored a cubed plus 8. How do you factor a cubed plus 8? A plus 2 times this big dude divided by a plus 2. Now what can I do? Yeah, the a plus 2 cancels because division kills the multiplication. Of course, students just immediately start to do this. It's a very human thing to want to do. You're like, kill stuff. Very human thing. Right? Or cancel stuff if you want to be less animalistic about it. Okay. Cool. Alright. So last idea for the day. I don't remember what the book calls it, but it's the zero product property. That sounds so much more intense than it really is. Let me just say this without writing anything. If I told you I have 2 numbers, and when I multiply them, I get 0, what has to be true? What is there no escape from? What must be true? I have 2 numbers, and when I multiply them, I get 0. One of them, or both, has to be 0. So if I have a times b equals 0, then a equals 0 or b equals 0. There's no freaking way around it. Now, if I told you I have two numbers and they multiply to be 8, is there any restriction on what one of them has to be? 2 times 4 is 8. 8 times 1 is 8. 16 times 1/2 is 8. 800 times 100th is 8. So there's an infinite number of things that can each be. So that's no good. That's bullshit. I need two things multiplying to become 0, and then I can say something about them. So, for example, if I had this number times this number is 0. What must be true? Either this number is 0, either this number is 0, or the other number is 0. One of those has to be true. Now, just on the surface of it, think of x minus 1 as the name of a number. So either the x minus 1 number has to be 0, or the x plus 4 number has to be 0. There's no other freaking way around it. If neither one of them is 0,